All right, another thing I want you guys to realize is that when you're simplifying radicals, you can actually use the exponent rules that we related last class, where you can write this is the denominator and this as the numerator, and that will actually help you simplify and reduce things a lot of times faster, and in my opinion easier. Okay, so what we can do here, okay, this is just the cube root of each of those. The cube root of 64, we can kind of do that. We can use our calculator. We can use, memorize what cubed gives you 64. But so this one you can actually work out. We can just work that out to the cube root of 64. Okay, and we're going to get that one in a second. Now the variable, I would actually approach it differently. Instead of thinking of it as cube root of y to the 6th, let's relate that to exponent rules. So if we think back to last class, we said that the root is the denominator, and we said that the power is the numerator. And the only thing that you might be thinking is, well, last time the power was on the outside. And that's true. It doesn't matter where the power is. If the power is on the inside, it's still the numerator. If it's on the outside, it's still the numerator. And what happens when you make that fraction, it actually will reduce, and then you've got your answer. So if we look at them separately, the cube root of 64 is just, let me put in equals right here. Oof. All right, so the cube root of 64 is the number 4, so we could actually evaluate that one. And then 6 divided by 3 is just 2, so that's just y squared. All right, so the cube root we could work out. We changed the roots and the powers to simplify, and we actually got a nice, much better answer. This is the simplified version, 4y squared. All right, so here we don't have a number, so we don't have to worry about actually getting that number and rooting it, but we can take each of these and make it a fraction. So remember, last class, or in the past, we've talked about if you've got a fraction, you can separate them, you can put them together, the different rules, but they are both being fourth rooted, plus they both have a power. So let's look at them separately. Let's say m, okay, this is the denominator, this one's the numerator. So when we actually divide that, we get m to the first. All right, then we look at the denominator, oof, n. This is the denominator, this power is the numerator, and 8 divided by 4 just reduces down to squared. So it's really m to the first, and you don't really need it. You can, if you just see that, it's the same thing. But this reduces down to m to the first, or m, divided by n squared. And it is simplified. All right? So taking your roots and your powers and making that fraction can be really helpful. It can really help you clean up your powers a lot easier. All right, now, sometimes they don't divide evenly. So here, 4 divided by 4, that divided. 8 divided by 4, it divided. These divided evenly. If it doesn't divide evenly, you just have a remainder, and the remainder just stays within the root that we're given. So let's take this and let's separate them. The fifth root of 4, that's actually not going to simplify, so that's going to stay inside the root. All right. Then let's rewrite these. Let's rewrite each of these. So this is a to the 8/5. It's not going to divide evenly, so I'll show you where to put your leftovers. B to the 14/5. All right, that's also not going to divide evenly, so we're going to have leftovers. And then C to the 5/5. That one is going to divide, so that one will look more similar to like what we had here. So what we want to do, now that we have written them in fractions, we can divide, and now we can actually write some of them as exponents like we did here, or since we've got some remainders, they are going to remain inside the root with this 4, because that 4 can't fifth root. So let's go through and let's look at them separately. All right, just like when we simplified roots in the past, I want you to, all right, I know I go through and I write my root on one side and I write my answers on the other. So let me have a little bit more room. So what happens is as I go to each part, I'm gonna put some of it outside and I'm gonna leave some of it inside. So we just said that the fifth root of 4, that's not going anywhere. You cannot pull anything out, you can't fifth root it, so that's gonna stay right where it is. All right? Now, 8 divided by 5, that does divide. It divides one time, so that means you can pull one of your A's out. Okay? 8 divided by 5 is 1, and then there's a remainder. Well, the remainder, what's the remainder? If you divide 8 divided by 5, you get a 3. So the remainder is what you still write remaining inside of that root. All right? So that reduces this one. Okay, 14 divided by 5. Well, how many times does 5 go into 14 when you divide it? That would be 2 times. So you could pull out a b squared because 5 goes into 14 2 times. The remainder would be a 4. So b to the 4th, those 4 remaining ones would stay there. And then we already said that 5 divided by 5, that works out. That is just c to the 1st, or c, and that one is gone. There's no remainder, so you wouldn't have anything left in there. All right, so it looks awfully colorful, but this would be our final answer, where if they didn't divide evenly, and again, those ones are automatic, so you probably wouldn't see them. If they don't divide evenly, you divide what you can, however many you get is what you pull out, and then the remainder, whatever you couldn't divide, is how many you write left. That's how many you have left. We'll say it that way. All right, so these are pretty easy. This kind of goes back to our adding and our subtracting. The root W's match, so all we have to do is combine our 1/5 and our 3/5. Okay, so we just combine them. 1/5 plus 3/5 is 4/5. Root W. All right, so whether we're talking about variables or whether we're talking about numbers, as long as we're looking inside the root, that base, we need to make sure that they match. And then we could just combine the coefficients, the numbers up front. All right, same thing here. X and Y match. Y is to the 1/4. Everything matches. So we just combine our 3 with our 8. And we get, and be careful, in this case it's subtracting. So we get -5 x, y to the 1/4. The x and the y match, so we just put the coefficients together. All right, so that's kind of reviewing that adding and subtracting. But again, this is bringing back to where if they don't match, that means you have to clean it up a little bit. So I will give you a hint. This is what I look for. All right, when I look for things, I say, okay, here's a 2 right here. That means that this 54 is going to break down to 2 and something. All right, because these 2's are going to need to match. All right, and then there's a z squared right here. So chances are, this is going to turn into a z squared. And we're going to see that in a second. So let's first clean this one up. What color? All right, the 12 isn't going to move. All right, the cube root of 2, that's not going to move because you can't cube root 2. Again, they're going to match anyway. Let me make sure there's a little 3 right there. All right, so, but we could clean this up. This changes to z to the 5/3. This is the denominator, there's the numerator. How many times does 3 go into 5? Or what is 5 divided by 3? Well, that is 1 time. So I can pull one of the z's out. All right, and then you ask yourself, again, this is sitting here. We can't move it. So we pulled one of the z's out. And then what is our remainder? Well, 5 minus that 3 is a 2. So we have a z squared that's left. All right, so there's the z squared that we were talking about matching. All right, so one of the z's comes out. That we had 2 as a remainder, so that left us with a z squared inside. Well, now we're taking away. Z is already out front. So now let's clean this one up. Why, we already said that 54 is 2 times 27. Thankfully for us, you can cube root 27. The cube root of 27, pardon me, is just 3. The more we use cube roots, the more you'll recognize them. We'll probably make some flashcards or something. So, if you look, that means I have the cube root of 2 left. And, pardon me, the only thing I didn't do is I didn't write down the z squared. But really, it's there. So the z squared comes down here, but we didn't do anything with it, so it comes down here. Now, if you notice, these match. The cube root of 2z squared, the cube root of 2z squared. So, we can actually combine them. This looks a little funny, so I would write it as 12z times the cube root of 2z squared minus, I would just rewrite that as 3z. That's just how we're used to seeing it. And then again, we have another cube root of 2z squared. Now we can just put these together. What is 12z minus 3z? It is just 9z. And then since these match, we just tack that onto the end. Cube root of 2z squared. So again, the adding and subtracting is the easy part. It's the simplifying, getting them to match so that you can do the easy part. All right, so you should have time to practice, and hopefully it'll come as you guys practice more and ask your questions. All right.